Hello, and thank you for attending our Solid Edge Electrical Design webinar today. My name is Creech, and I'm an application engineer with Prolim, located in Cincinnati, Ohio. A little bit about myself, if you're not familiar already. I have over 20 years of end-user design engineering experience. During that time, I've worked in the manufacturing, architectural, and automotive design industries. I built a strong working knowledge of most popular 3D design softwares, such as Inventor, CATIA, SolidWorks, several Autodesk products, and obviously Solid Edge. As mentioned, I'm currently a Solid Edge application engineer with a focus on mechanical and electrical design platforms. My career interests include generative design, additive manufacturing, and process improvement, or Kaizen. Today we'll be discussing the following Solid Edge electrical topics. We're going to look at the leading trends, industrial leading technologies. We'll also be looking at wiring design and harness design environments, and then we'll look at connecting these environments along with design rule checkers and system simulations. Let's first talk about today's industry trends. We are seeing an increasing demand in the need for customizable, Wi-Fi integrated, or smart connected products. You see them every day: your cell phone, TVs, refrigerators, vacuum cleaners, even lawnmowers. In a recent survey, engineering teams were asked what value they see in their electrical systems of their new products. 71% of those asked said that the value was increasing. And 37% of that group said that the value was increasing significantly. So that tells us that the electronics, the electric components, and the smart connected products are really what's driving this industry growth. With that being said, the graph on the right shows the impact of these ever-growing, more complex, smart connected products. More complexities mean longer delays in getting the product to the market, and design inefficiencies, maybe outdated software, processes, etc. This is currently a very big challenge for most companies that are facing today while trying to grasp and keep up with this growing trend. Along with the complexities of electrical designs, a great deal of compliance and regulations must be adhered to. Not to mention all the industry and safety standards, these must be met. So it's vital that we have the tools that allow us the ability to control these measures and the visibility and transparency to show that these guidelines are being followed and met. Like any new technology trend, you must be able to evaluate your current design processes, methods, and software put in place and identify the areas where you need to improve or enhance, thus the Kaizen, so that you can really leverage and capitalize on this ever-evolving technology and its growth. Here are a few product examples that would be a great fit for Solid Edge wire and harness design. Most having several wire and harness designs connected to the various internal electronic systems within the product. A lot of these harness designs are driven by the wiring design or the schematic. Here's another example from the industrial machining industry. We see a control panel or panel design that lays out the actual wiring and connections of the device along with the devices themselves. As opposed to the harness design, as we saw in the last slide, this is critical for the electrical engineers to convey the connected instructions to assemblers of the control panel such as this. The wire design or schematic specifies the routing of the wires, the wire gauges, lengths, colors, and the type of connections and devices which are connected. Now let's briefly talk about the industry-leading technology. In case you're not familiar, Siemens recently acquired Mentor Graphics in 2017. One of those large acquisitions was a product called Mentor Graphics, or Mentor Capital. This is an enterprise solution for electrical design that has been around for a very long time, with many existing users. This product was targeted towards the large automotive and aerospace industries. It's a very powerful tool. Siemens has leveraged this tool now to target the small and mid-sized businesses and existing Solid Edge users, thus introducing Solid Edge wiring harness design. As mentioned, this isn't a new software, just better leveraged to accommodate the smaller and mid-sized businesses in efforts to help the Solid Edge users access this technology to better help them complete their electrical designs more efficiently. So, as you can see, Siemens is consistently evolving and growing its portfolio of products to better support the growing customer and the technologies. With the 7 main pillars of the design phase, you can see how the Solid Edge wiring and harness design fits perfectly into this, further bridging the design gap. The image here depicts a very common design method happening today. Most MCAD and ECAD teams are completely segregated and rarely communicate with each other along the design process. In most cases, data isn't shared until the very end of the design stage. And when this happens, we find any irregularities or restraints are identified on either side. The changes can be very time consuming and result in wasting valuable time and even delaying time to market. No good. These two teams are likely using different softwares as well. This becomes even more of a challenge when ECAD tools are not intelligent. For example, AutoCAD or Visio, or maybe even using the solid edge drafting environment. This prevents quickly updating changes across the MCAD environment or the bill of material. Even more wasted manual work is required. But there is a better way. Solid edge and wiring harness design brings these two environments together, giving the user the ability to communicate and share data between ECAD and MCAD environments using connected mode, greatly improving the communication between electrical and mechanical teams, thus saving extremely valuable time and effort during the design phase. Here's a quick look at the solid edge wire and harness design modules. On the far left, we have solid edge wiring design. This is an environment where the users will select and place wires, connectors, symbols, devices, and parts from their electrical parts library. This environment also allows for system simulation and design rule checkers. Next is the solid edge wire harness design. If a customer requires harness designs, the wire and harness design modules can be coupled together to seamlessly share data and design elements between each other. No need to re-enter previously configured designs in each environment. We simply add the physical harness components here as needed to complete the design system. On the right-hand side, we have solid edge MCAD environment. This environment allows users to share and exchange information from ECAD to the MCAD side, allowing for routing of wires and bundles throughout the MCAD assemblies. If changes are made in one environment, they are carried over and displayed in another environment automatically. But it's important to mention here that both the wire and harness design environments can be run as standalone modules apart from each other in solid edge MCAD if so required. Many customers only require one or the other. The flexibility is there when you need it. This also makes the software much more affordable, only paying for what you need when you need it. Here we'll see the value of intelligent diagrams and the electrical parts library. We'll also see styling and standardization and templates, so that all users are pulling from the same central library for their borders, commonly used parts, symbols, and design templates. We also have design rule checkers. This allows the application to run real-time system checks in the background, consistently checking for electrical issues and validating the system for accuracy. Simulation is another valuable tool that is included in the software. Here you can validate the system by running a simulation to see if the electrical components are functioning correctly. For example, moving switches to different positions. We also have the ability to review currents, signal strengths, and voltage going through the wires. That helps us determine appropriate wire size and fuses required for the functioning system and optimizing our design. The electrical parts library is another vital part of the software. Every seat of solid edge wire and harness comes with this included electrical parts library, with over 4,000 symbols and parts and growing that you have to choose from. IEC, ANSI, and other electrical standards are available for install. This is where all symbols and parts are managed. As users build and add custom, commonly used parts and symbols that may not be included in the library, they are saved to the library so that the rest of the team can pull from them. One central location for all users to access standard components. Here's a quick look at the design rule checker. The checker is validating for 4 different categories. Appearance. This could be a pin not set on the grid or overlapping a conductor. The connectivity checks are looking at devices that may not be connected or wires being not connected properly. Library consistency is another key checker. This is looking for wire fit, cavity mismatches, etc. The dialog box here at the bottom is an example of a result from the design rule checking points. The line item highlighted in blue is telling us that the wire is a mismatch for the cavity we have set up. Clearly, this is something that using other design processes may not have been caught until the prototype phase, or worse, in the field. The red text highlighting in any of the messages, if clicked on, will take you directly to the area of concern so that you can modify and make the corrections. This is very helpful when dealing with multiple sheets and very complex schematics. Simulation is another great tool. In this example, if you look at the circuit simulation, the green wire are indicated that we have signal flow through. The cyan color is indicating no current. We can easily manipulate the switches to validate if the connectivity is functioning correctly or not. If you look at the dialog box in the lower right, this is indicating the signal strength of the chosen wire. Here we can verify the wire configuration is appropriate and don't violate any constraints. For those that are new to the software, I want to spend just a moment on the data flow for this application and its connected mode. Connected mode is a tool that allows us to share data bidirectional between electrical and mechanical tools, as mentioned before. So as you can see here, we are pulling symbols and parts from the library and building our 2D schematic or harness design. And once that data is complete or available, it can then be shared to the Solid Edge MCAD environment when connected using the Solid Edge electrical routing element. Once the data is shared with the MCAD team, wires and bundles are routed throughout the assembly and any changes that are needed, wire links, plugs, bundles, etc., they can then be shared back to the ECAD team so the electrical components can be updated. Connected mode also has the ability to take harness design information from Solid Edge MCAD and convert it over to the harness design application. This is what's called 2D flattening. True synchronization at its best. Now let's go ahead and take a look at this in action. So now that we got the tool open, we'll go ahead and open up a project. I'm just going to use the default Quick Start project here for the Quick Start transportation. Click OK. And you can see here now we've got a project open up here, and you can see there are some categories here that we can select and expand upon. I'm going to quickly, briefly look at a harness design. And again, this project can include harness designs and wiring all together in one project bundle. But kind of just to give you a quick overview and a kind of a little bit of understanding of how a harness design can look. So you have your device here on the left, and it's identified by its components. So this is more kind of I would say more of a bill of material, a visual bill of material. So you get the pin numbers, cavities, you get the numbers, a lot of information in here. And again, this is all brought in using just the default parameters, but this can all be customized. And again, I won't get too much into harness design for this specific webinar, but I'll be doing a future webinar to go more in detail into the harness design. For now, we're really going to just stick to the wiring design at this point. So I'll go ahead and close this. And now you can see I closed that design, but I still have the project is still activated and open. So now I'm going to go ahead and look at the wiring diagrams here, and you can see I've got 9 different options I can choose. Each one of these is a different design layout. So let's go ahead and open up these. So one thing to keep in mind on your browser over here, so once we have a design or a schematic open, we have this design panel. And anything that has a plus, you can see has components attached to that, and we'll go into those a little deeper as we go along here. And one interesting thing here, when we expand these, some of these aren't necessarily stop. So as we start kind of navigating through this, I want you to notice a couple of things here just to kind of simplify some of the navigation challenges here. So if we got a big list of items over here and we're not really 100% sure where they are or where they're located, if you simply just select any of these over here in the design tab, you can see they highlight in the graphics window. So very very easily identifiable ways here. And traversely, if you are in the design window here and you're looking for this and you want a little bit more detail as to what that is, you select that and it's going to highlight it over here in the design tab as well. I'll briefly hit on how to navigate through this environment. The navigation controls are the same from the wiring design to the harness design. But I will note that there are most of the controls, navigation controls, are very similar to all other CAD softwares. But there are a few unique ones with this tool that are different from all the others. And it may take a little getting used to, but there's a cheat sheet available, such as these stroke commands. So as you can see, if I hold in my middle mouse button, it's giving me this red thing here. So depending on what direction I'm going in, you can see I'm zooming out in increments. Now if I come the opposite direction, I can zoom in, out, and I can also zoom in entirely too far, and then I can also zoom out or zoom all. Your middle mouse button works as it does in Solid Edge, zoom in and out, scroll up and down, but we won't get too much into that. But when you first get into the tool, and especially if you're bouncing back and forth from Solid Edge to this, it might be a little tedious. But like I said, within a few days of being exposed to and understanding what those tools are, you pick them up very quickly, and it's not a big deal. It's just kind of a unique tool. So as I mentioned before, when you select a device or a connector here, we're able to kind of quickly visualize what's here. But again, if you notice, we've got 9 different pages that are all part of this one project. So we're currently only looking at what is relevant to this one design, so sheet number 3. But we do have the ability, if we know what we're looking for, we just don't remember what sheet it is. We know that it's part of this design. It's not on this sheet. We need help kind of locating it. So there's a little quick button here that shows you can toggle between showing just the relevant to the particular sheet, or you can click this and now it shows all the devices. Which is really handy. So for instance, if we want to find, let's say this speaker subwoofer, let me change sheets here. Let's say we were here. We were here, but we wanted to locate this subwoofer that's on another sheet. So if we find it here, again, we're clicking it, but it's not showing up anywhere here. So if we just hit Z, it takes us directly to that location. So it changed from sheet 7 to sheet 3, and it takes us directly into this area, zoomed in, so we now can configure what we need to change or locate accordingly. And speaking of changes, if we wanted to change this device, if we right click on the part itself, we can go to Properties, and we have the ability to manipulate, change the name, swap it out with another part library, or a part from the library. We also can see some other information in regards to this specific part. And at the same time, we can also right-click on the actual component itself. Same, go to Properties, and here we back are in the same location. So there's a lot of different ways to get to the same information. So depending on where you're at on your display screen, it might be quicker to right-click directly from the design panel, or if you're in the graphic window, it's easier to just select and right-click directly from the graphics window. So, again, another really cool feature that's kind of accommodating and fast-tracking your design process as much as possible. Next, I want to talk about off-sheet references. Off-sheet references seem to be a pretty common question when customers or potential customers are looking at this new software and wondering how they can, how can you configure off-sheet references, and does it allow off-sheet references? And the answer is yes. That is set up by default. And not only is it set up by default, but you also have the ability to kind of manipulate and change and control those templates depending on your company's profile. So let's go ahead and open up this sheet here. I think this has some off-sheet references. As you can see here, this wire is being referenced from to another sheet, and you can see that actually these 3 wires. Let's just look at this one for instance. Looks like it's on sheet 4, And the cool thing about this, the naming convention is it's dummy proof. It's going to tell you exactly where this wire is also used or being referenced to or from. So it's on sheet 4, front lighting. You can see that's this sheet here. Also, the 3-B is going to be the location, the grid location. So we've got numbers and letters here to kind of give us a more general idea of where that might be present. And again, you can also tell that this one here, this specific wire here, is being used on sheet 6 as well, sheet 7, and sheet 8. So a very, very quick, easy reference guide in order to figure out where things are being referenced in other sheets or other parts of the project. And just to briefly hit on how you would change these, to set up your own company standards, you simply just right-click on the property, go to Style, and you can go to Edit Style. And this is going to open up this dialog box here. It's going to have all of the information that you're going to want to set for your specific needs, and as far as setting up your templates and the way you want these things to look. You can add additional parameters in there to look at. You can remove parameters, but all very easy. And again, you can just click from this attributes section here. Very easy to apply the styles, exclude certain parts of the styles. So now that we've kind of explored some of just the basic functionality of the wiring diagram, let's look at exporting out a project. So again, this is an existing project, and here shortly we'll go through creating a new wire diagram, so you can kind of get a feel for how to create these things from a very high level view. But for now, let's look at we've got a project complete, and now we need to export this out to share to the rest of the team. So if we go up here to our Home tab, we have this print control here. The drop down, we have print and print to file. So we'll go ahead and select a print to file, and we're gonna output this as a PDF. It's pretty common exporting format that most people can use if they have access to just a simple computer. So you can see here we have the option to select either the entire project to convert just the specific design that we're looking at, or a diagram in specific. So if we just wanted to use one of these diagrams, we have the ability to do that. But for now, we're going to go ahead and just do a design. We want to select a PDF now, but you do have the option to output this as a DXF, a CGM, or a CVG file. For now, we'll just select PDF. And again, we can configure that if we wanted to go in here and make some changes, color it from black and white to color. The black and white, at least for this setting, doesn't work too well. So we'll use color. Hit the page, single, let's go 11 by 17 to make it a little bit more legible. Hit OK. And again, we can select the different formatting for the file name. Right now, it's gonna save it as the diagram name. Location is gonna be fine. Hit OK. There we go. Okay. So now the PDF has been converted. You can see it down here in our window that it's done converting. And the cool thing is now we don't have to navigate to that. We can literally just grab it right from here. So we double click this text, pulls up our PDF, and you can see now that we've got all 9 sheets all right here, very easy to use, laid out in the same order as the design itself. And if we look at our bookmarks over here, we have previews of each one, but then we even have each one of these titles have brought over as well. So again, a very simple, easy to use exporting option. A great little tool, and we can save this out and now share it with people that don't have the actual tool for review, whatever it may be, even for installation if that's the case. Now let's explore the toolbox a little deeper here with our existing project. We'll go over to the Drawings tab, and you'll notice we've got this handy little Add Diagram List table. So if you hit the drop down here, you see we have the ability to generate a diagram list, a device list, a wire list, whatever we're looking to pull from. So I'm going to go ahead and do a diagram list for this part here. You simply select it. I don't have to select any of the parts. It already identifies that I want to create this list on this specific sheet. So again, it's already, you can see my cursor's got the little graph on there, so it's already telling me where do you want to put it. Go ahead and place that here, zoom into it a little bit, and just to kind of get an idea of what this is looking like. So again, it's kind of giving us a diagram of all of our sheets, the names, and again, this is all dynamic. So if I wanted to go in here and change any of this stuff, let's say, let's go ahead and change power. I'm going to edit this. I'm going to test. You see that changes immediately. And it also goes to that sheet. So if we go back to our wiring diagram, you can see it's here. And now it's relabeled that tab as test as well. So you change it in one location, it's changing it across the board, which is a very, very handy tool. And again, you can move this anywhere. You have the ability to go in and add some additional columns if you needed. But let's go ahead and move over to another sheet here. So we'll look at another, back on our drawing tab again. Now this time we'll do a device list. So what this device list is going to do, it's going to populate all the devices that are for this, needed for this sheet. So depending on the complexity of the design, we'll see when we drop this here, usually it's a pretty big list. So we'll put it over here for now. And you can see I'm not having to do anything. I don't have to select anything. It's just populating that based on the intelligence and the information that it already has there. So we'll zoom in here, look at it a little closer. And you can see that we've got a full list of all the devices that are included in this sheet, what diagrams that they're associated to, a part description, and just a ton of information that's here just by default. And again, you can go into your style sets and change and add and remove any of these columns as you see fit. We can move this thing anywhere we want it to be. This would probably go in a separate sheet, but again, just at the very simplest form of creating documents. It took me a second to create that. And try one more. We'll go into this sheet here. Now we'll go in the same, and we'll just do a quick wire list. This one may fit. Nope, it's even bigger. So this is going to give you an even closer look at each one of the wire names, where it's coming from, what pin connector it's attached to, what cavity it's connected to, where it's going to. So again, and then you've got your full length here as well, so your cable lengths as well. Again, this is all just default information that is just given to you. So very handy, and again, that's going to be a big Excel sheet there, but kind of get the point. It's very easy to create these basic lists. So also included in the software is a really handy reports section. So if we review the workflow tab, we can see here we've got this really big reports command here, and it's got another drop down. So we have the ability to go into create reports, and there's already some pre-populated reports in here. All of these are pretty common reports. And just to kind of look at a few, you can do a connectors list, you can configure wire lists. We're just going to look at let's go ahead and look at this design wire list, and let's just view this report real quick. Generates. Now the reports default to an HTML export, but you can see it's a pretty intuitive list. It's got all the information you would ever need in order to have these wires cut to need in order to give off to your purchasing department. Very intuitive list. And you do have the ability, once you have this open here, to save this and print it either as an HTML file or a PDF. This may take a minute, so I'm not going to actually do it, but if you have a QPDF or Adobe PDF Writer, it just prints directly to a PDF. And again, these are just the default lists. You do have the ability to go in and build your own lists, and I won't get into building them too much. This is just an overview. But this Help tab here will actually pull up very intuitive, very user-friendly how to create your custom reports, which again is always a very helpful thing when you're new to the tool. So that's kind of a brief overview of how to kind of work within an existing project. Kind of the basics. Again, there's a lot of this application has a lot of tricks and tools and things that we can really get into. But I kind of just want to create an overview so you get a very brief understanding of the power of it. And as I said, I will get into much more detail in a few upcoming webinars to kind of get some more specifics out there to the people that may not be very familiar with this software just yet. So I'll go ahead and close this file. Next, we're going to look at stepping through the process of creating a simple new design. We'll create it just again a simple circuit, and then we'll run a quick simulation on that circuit to just kind of feel the power of the simulation, see how easy it is. And again, I still have the current project open, but there are no designs open. So I've got a couple of different options and ways I can go to create a new design. I can right-click on the project header and go to New Wiring Design, or I can go up here to Designs and select New Wiring Design from here. Now we have the ability to create, our name, and I'm going to show you something here. I'm going to go ahead and name this Wiring, and you notice right off the bat it's red. So this tool is very intuitive, and it is restrictive as far as being able to have multiple devices or components that have the same name. So it really tries to prevent you from having duplicate objects that may be a little different but have the same name. So this is one of those handy kind of visual warnings, helping you kind of get over that challenge. So I'm going to go ahead and just create new design. And again, you have some ability to determine the location or functionality. I'm going to just go ahead and hit OK here. And again, working with a default installation that I've got here, there are no styles or borders set up. I don't have anything really set up here. So you have the ability to go into the settings and create your own custom company templates and borders. But for now, I'm just going to go over to the drawing tab real quick, and there's this border button here. And now I can pull any of these templates in that I want to kind of play around with. So I'm just going to select this D size. And again, it's going to kind of show you some of the values and some of the information it's going to pull from the project and bring into this border. And so far we've only kind of explored this design tab. So you'll notice to the right we have a symbols tab and a parts tab and an analysis tab. We'll get into those three. But the first two, the symbols and the parts, now these are direct access to the library of parts and symbols that are installed, the sample installation when you install the software. And again, over 4,000 parts that you have access to. And you can see here we've got IEC, electrical, ANSI standards, all right here at your disposal. So now I'm going to build a simple circuit just pulling parts from this existing database. And we'll get into more detail in the future in regards to how to create new symbols and maybe some reoccurring parts and stuff that you guys currently use in your industry, but maybe they're not included in this ever so growing parts library. And we'll get into that detail as well. So we're going to first start by dropping a battery in place. And we can see here, we can kind of navigate down through here and find batteries, expand that. And we've got a couple of different selections here. And you notice here at the bottom, we're getting a quick preview of what the different options are here. So it kind of helps you better understand what you're going to be pulling in, maybe if you're not familiar with the name itself. So I'm going to go ahead and pull in a single cell battery here. And it's simple, just double click, and you can see I'm bringing it in here. Now one thing to kind of quickly identify is you can see that it's kind of snapping to a grid. So this solid edge electrical tool uses a minor and major grid point. So if you're experienced with using 2D schematics in an AutoCAD environment where you can pretty much just put things wherever you want, this is kind of one of those other control mechanisms set in place in the system to kind of keep you from putting things where they may not belong. So as we start to build this thing, you'll get a better understanding of why that is necessary. But we'll go ahead and just select this, drop the battery here. And now I guess one thing to kind of put in mind is we were able to kind of search for the battery here, and it gives us a couple of different options here. But if you notice down here at the bottom, there's this little browser window here. So we can also search and filter by text. So I just type in battery, we get a quick, all we're seeing is just the battery type, which is kind of handy. When you've got a ton of parts in here. Search for switches, and now it's going to just show us just switches. We can look for lamps, and now we are only seeing the filtered results there. So again, you know, it's nice to be able to see everything, just in case you're not sure what you need, but it's really good to be able to have that filter mechanism built in as well. We'll go to the others here, and we're going to look for just a single switch here. We'll bring that in. Again, you can kind of see how it's kind of aligning up. So now we've got our switch in place, and now we'll search for our lamp. Let's grab this guy. Now all we need is a couple of grounds. Put this guy down here. Now another cool thing here is if I just select this, hit Control C, Control V, now I'm able to copy and paste those as I need as well. So pretty user friendly. So now that we got a couple of components populated in this new design, if we go back to our design tab, we'll see now that we have devices highlighted here. So you know, we're kind of able to keep track, and again, if we just cross-reference, we're just selecting on one, it's going to highlight in the graphic window, and the same thing if we select it in here, it's going to highlight it over here on the left. So very handy, very user-friendly. So since this is a new design and then a fresh install, everything's kind of coming in as default naming conventions and stuff that all can be configured and set. But just to kind of show you how easy it is to change some of this stuff, let's go ahead and just rename some of this stuff. We just double click on the name. We're going to call this guy the battery. Here's our switch. And here's our lamp. And again, all dynamic. So as I'm changing it here, you can also see that it's changing over here as well. We've got ground 1 and 2 here. So now it's starting to come together a little bit. Now all we have to do is go back to our home tab, and now you can see we've got devices, splices, pins, wires. We're just going to add some wires here to connect this. And this is kind of where that major and minor grid really come into play. So you can see it's really snapping to those endpoints like almost instantaneously. So if I select endpoint to endpoint, hit enter to accept, and you can see that it already knows this is a wire. So it's already creating the offsets that we need. So we got some quick shortcut devices. If we just continue to hit W, that's going to bring us back into our wire command, and we'll just keep doing that. And it's important to note that that as we're going through this process, it's very important that you're making sure and you're verifying that you are selecting to those grid points. Otherwise, you may get an error. And there we go. So now we've got a simple, and you can also see we've got some generic names in here for the wires, and each one of those are unique wire names. And we have the ability, if we needed to simply double click wire number 1. Now you can see it turns red because I'm trying to name it the same wire name as the first one. So again, kind of just reiterating the inability to have multiple things with the same name. Now, to get around that, if you absolutely need to have two components that are different but have the same name, you do have the ability to go in and manipulate those names in the style sets. You're kind of just forcing it. You're hiding the actual generated name, and then you're creating basically an alternate name for that device. go. And again, it's all dynamic as I'm changing it here. It's updating over here in my conductors, wire 1, 2, 3, and 4. So now I think we're ready to go ahead and simulate this simple circuit here. So again, very, very easy. We'll navigate over here to our analysis tab. Unable to set scope. So first we've got to create a scope. Now, again, I'm just selecting, it's implementing or pulling in all the information that it needs. So I don't have to change anything. It's already ready to simulate. So I'm going to go ahead and hit run the simulation. It's running on the other screen here. And now it's completed the simulation. It's given us some results here. So if you remember in my previous slides, I had mentioned when you run simulations, you get different colors that kind of tell you different things. By default, the cyan is telling us that this circuit has no connectivity. There is no power running through this circuit. So as you can see here, there's this, it automatically recognizes there's a device that has a few different positions. So if we choose this position from open to closed, it regenerates, and now you can see that it's a green circuit. It's fully operational and is operating as intended. So again, a very, very powerful but yet very easy to use tool. Now, if we want to, we can go in and kind of dig a little further, and now we can create a numeric simulation. So what this is going to do is it's going to basically repopulate the study simulation, and now it's going to give us a little bit deeper information. So now when we hover over this, we can actually see the current and voltage that's being run through this simulation. We have the ability to close the circuit out, short the battery. Pretty handy stuff. And again, we can even, we change the position over here, but even if we hover over the switch and turn it back to open, you can see it's going to rerun that and turn us back to cyan, meaning there's no connectivity. So we'll go back to closed. Again, very, very handy, very easy to use, yet powerful tool. This is a very simple simulation that we created just from a simple circuit that we developed. If we were to go and open up another device, let's say we open up one of these previously reviewed designs. Now we don't have to do anything special with this one. Now this is a more intricate, more detailed system here. And again, if we just go to our analysis tab, we select to generate our scope. It's writing our scope. And now when we go through here, you can see that it's identified all of the different devices that are attributed to this design. So now we're just going to hit simulate. This is going to may take a few minutes. It's running the simulation, running in the background. And now you can see it basically does the same thing. So it's going to default to have any switch that you have off. And you can see all of the different controls are immediately automatically identified, and you have the ability to go in and test each one of these. Now I'm not really familiar with this individual design, the system. I didn't design it, so a little unfamiliar with it in terms of what happens when I turn certain things off or open. But you can see as you go through and toggle these things, it's going to repopulate the design, and now it's going to show you certain areas that have current and certain areas that don't. And again, but if we were to go in here and do a numeric simulation, runs the same simulation again. Now as we hover over them, we get more detailed information. So again, very powerful tool, very easy to use, and also gives you the ability to control and manipulate a lot of this information to get the desired results that you need. So we've looked at kind of navigating and kind of playing around in some existing projects and designs and schematics that have already been created, and looked at a couple of wire harnesses, and we've even created a very simple circuit, ran some simulations. Now we're going to kind of look at what happens when you're very early on in the preliminary stages of creating a system, and you're really not sure if the parts exist in the library or not, or maybe you're not even at that point where you even know what configurations you want. So I'm going to close this. I'm going to go ahead and open up one more thing here. Look at my device blank here. So again, now we're in the scenario where we're not really sure what we need, but we just want to start laying some stuff out. So we have the ability to go in and just create a device. And again, it's very simple. It is snapping to that grid, which is what we want. And we're just going to throw two quick things down here real quick. You can see the device comes in, no real detail. If we want to change or manipulate it, once we have it set in place, we can. And now what we're going to do is just create a couple of pins for this device. So I can create individual pins, and it's kind of hard to see, but when you zoom in here, you can see all of the predefined pin locations that you can select. And again, that's based on some electrical standard. So I'm going to say I've got a few pins. There we go. And now that I got the pins in place, I still have the ability to go in and kind of change these things around as needed. Not really sure what I need just yet, but I'm going to just create some stuff. So here's another device. We'll create this guy over here. And you can tell the window above the cursor is kind of giving us an idea of, based on the width and then the size of this device, how many pins we can get in this one device. And again, this will all be based on your company standards and your electrical standards that you guys follow. But we'll run through this process one more time. We'll create a couple of devices here, or I'm sorry, a couple more pins. Okay, so now we've got the pin set in place. We've got two devices here, again, very generic. We're just trying to kind of lay some stuff out to figure out what we need. And now I'm going to go ahead and add a couple of wires here, and I want you to see something that's really cool. So we also have the ability to do multi-connect by wire. So, and again, it's going to give you a quick preview of what we're looking to do here. And let's just say, for instance, we want to take these 4 pins, and we want to create a wire that connect to these 4 pins. So I hit enter to accept, and you can see it automatically populates, it auto routes the parts based on my need. I even have the ability to kind of move these parts around, and you can see no matter what the placement is that I'm kind of manipulating and moving around, it's automatically updating and reconfiguring the placement of these wires based on the standards that are set in place. So never, we're never able to kind of overlap wires. It's all a very intelligent, easy to use tool. So in summary, we discussed the electrical industry trends and leading technologies. We saw the ability to create intelligent diagrams and schematics that hold us to the ever-growing electrical standards and disciplines that we see today. We explored electrical libraries and the simplicity to add and pull from them. We reviewed the harness design environment and both created a few new wiring designs. We then applied some styling attributes to the designs, and then we ran simulation studies to confirm functionality of our designs. In addition, Siemens is offering a 30-day trial of the wire and harness design modules. This is a great opportunity for you and your business to test drive the software to determine if it's the right tool for you. I'm thinking it will be. And finally, as previously mentioned, these software modules can be run independently of one another for better flexibility and cost effectiveness to meet your business needs. With all that being said, this will conclude today's Solid Edge Wire and Harness Design webinar. As I mentioned, we'll be adding much more content on this subject in the very near future. So stay tuned and please subscribe to our YouTube page for future webinars and for this webinar. At this time, we'll take any questions you may have. And if there are no questions, please feel free to direct any future questions to the contact information you see here. Thank you all for attending and have a great day.